first of all, C declaration. C declaration is what actually was a standard for C, right? Is what's called a caller cleanup. Means the function that's actually doing the calling is the one that's cleaning up the stack. That's what it's doing. Let me share with you the screen. So you can notice, you can see that we're actually using C declaration, right? It says here, right? We're quantifying the function to be a Cdecl function, okay? And what we're doing is, if we take a look at the disassembly and we look at the function, you see that the calling function does the stack cleanup, okay? That's why after it called foo, it still had to add 8 bytes to the stack, so the stack pointer moves back to the location where it was. Just to remind you from our previous discussion in the previous segment, so we had our stack pointer, and the stack pointer was holding at a certain place. I think it was B, whatever it was, but here it doesn't make a difference. It's holding here at B8, whatever it was. And after the function, we run the function, right? And we run the whole function, and we move forward. And we run in the function, we move back to here. Notice that we came back from the function. We have our return address right there. We actually saw it last time. This was the return address. And if you take a look at this, the same return address, right? It's a 012F17C9. And we have over here the EBP of the previous segment. We have our 8 and 9, they got increased by 1. But notice that the stack pointer, before we called the function, the stack pointer was holding at E4. And now it's holding at, sorry, I was holding at E8. It was holding at E8 at this byte right here. And now it's holding at E0, which means 8 bytes further up the runtime stack, because nobody moved and cleaned off the return value. Nobody cleaned off the parameters that the calling function put on the stack. No, the called function did not clean them off the stack, which means the called function only cleaned off the stack what it itself put on the stack. But the two parameters, the 8 and the 9 that we see there, those are parameters that the caller pushed onto the stack. And therefore in C declaration, it's the caller's job to clean them off the stack. And therefore you see that after the function call returns, we have an add ESP8, which what that does, it actually moves the stack pointer back to E8, which was right here. And if you think about E8, where was E8? To E8, which was right there, okay? Notice the 8 and the 9 are still there. We don't care though, because they're further up from the runtime stack, and therefore they are garbage as far as I'm concerned. They can be reused, they've been recycled. But we're back to this point. So who's the one who cleaned off the stack? The one who cleaned off the stack was the one who put the parameters on the stack, and that's the calling function. Now, the parameters in C declaration are pushed onto the stack from right to left, from last to first. If you just take a look at the screen right now, and you take a look and you see the function calling was foo_ab. That's how we call the function. But if you take a look how they get pushed onto the stack, first B gets pushed onto the stack, and then A gets pushed onto the stack, which means they're being pushed onto the stack from right to left. What is the advantage of that? The advantage of that is that when we look afterwards at the stack, and we look at EBP, once we're within the function, we're inside the function, so we are using offsets from the EBP to access the data. Now the EBP would actually hold, will be exactly at this position right here, this address right here. So notice that first variable is closer to it. It's EBP plus 4. That will be the first variable. And the second variable is going to be at EBP plus 8. So in a sense, by pushing them backwards onto the stack, they're actually facing forwards when we are within the function. And therefore, C declaration pushes them backwards onto the stack. So that's the second thing, a very important thing to talk about. Parameters are passed on the stack. We already mentioned that, okay? So, and the last thing I want to talk about is name mangling. So how can we see the name being mangled? So the way we get to see that is, let's take a look. What would happen? What would the linker error look like if I go and I omit the implementation of the function? Okay, I am declaring there is a function, so the compiler is going to be quite happy about that, but I'm going to omit the implementation of the function. Okay, so that's going to give me a linker error. I want to take a look at the linker error and see what it says. It's going to say I am looking for some function. And let's take a look at the name of the function it's looking for. So there we have it. Okay, we have the function. Notice what it says. It says unresolved external symbol, void Cdecl foo int. That's the function we're looking for. Notice in parentheses it's giving you the name of how it actually looks, what it's actually looking for. It's looking for foo, and then we have the at, and we have the y, a, x, h, and the at z. Those things are encoding for the parameters. If I go and I change the parameters, let me go change the parameters. Let's make this a character. And we'll call it with a character. Let's just call it with a character, I don't know, character C, right? And now let's compile it. You're going to see that the name changed. Okay, the name is going to change. And there we go, the name changed. And if you take a look at now, it actually says YAXHD, right? Notice that the name here changed. And you see that what's going on is that the compiler is putting into the actual function, the compiler is actually putting the types of parameters that are inside. And that's the way, by the way, how function overloading works. If we had two functions, let's make another function. And we'll call it, let's just copy that. And just change it here to character. Okay, and we'll call it here foo a comma c. And let's take a look at the runtime, the errors we'll have now. We're going to notice it has two different names. Okay, let's take a look at the errors. Notice we're missing two different functions. And if you actually look at the name that the compiler gave it, it's actually not the same name. And that's how function overloading works. And that's known as name mangling. When I go and I change it from C declaration to, let's say, standard call, which I'll do in a minute, so you're going to see that the format of the name changes. And that's part of the standard calling convention.